Elections aren't just about who's most popular, they're about who's least unpopular. And sometimes the rules of the game decide the winner more than the voters do. With two candidates, it's simple. May's theorem proves majority rule is the only fair way. Winner takes more than half the votes, end of story. Add a third candidate, and things get messy. The simplest way of voting for three or more candidates is called plurality voting, where you get one vote for one person. Essentially, an extension of the simple majority rule. Here's an example. Molly, Addie, and Lily are running for president of a country with 100 voters. Molly got 45 votes, Addie got 44 votes, and Lily got 11 votes. The use of plurality voting declares Molly a winner. However, if the voters are asked to rank the candidates, we can see how this outcome might not have been completely fair. If we take Lily out of the equation and recount the votes, then Addie walks away the winner with 51 votes to Molly's 49. A very similar thing happens when we take away Molly. Addie wins with 66 votes, and Lily loses with 34. Addie wins in head-to-head elections against Molly and Lily separately, but ultimately loses in an election with both of them. This makes her a Condorcet winner, something a fair voting system wouldn't ever have. This isn't just theory either. The example I just showed you isn't made up. Each of my friends actually represented a real politician who ran for U.S. Senate in New York in the 80s. Al D'Amato, Elizabeth Holtzman, and Jacob Javits. Holtzman and Javits were both liberals, and Holtzman likely would have beaten D'Amato in a head-to-head race, but Javitz's presence split the liberal vote, letting D'Amato win despite less than 50% support. Plurality is simple, but not always fair. Voting system built on the Borda count seem more reasonable at first glance. In Borda counting, each candidate is ranked by the voter and then assigned points based on how many candidates were ranked below them. Let's say that Molly, Lily, and Addie are running for president in a country with 5 voters. 3 voters rank Molly, Lily, Addie. 2 voters rank Addie, Lily, Molly. In this election, Molly would win with 6 points. Seems fair, but Borda count fails to fulfill a property known as independence of irrelevant alternatives, or IIA. Basically, Lily shouldn't beat Molly if no one changes their preference between them. But if these 2 voters reorder to Lily, Addie, Molly, Lily beats Molly with 7 points, even though no one changed their mind about Molly versus Lily. This shows that the Borda count does not satisfy the independence of irrelevant alternatives. Then there's the problem of manipulability. Let's say that these initial rankings represent the true preference of the voters. If the voters are all sincere, then Molly wins, as we saw, with 6 points. But Molly is the least preferred candidate of these 2 voters, so they might be pushed to rank Lily first to dethrone Molly, even though they really prefer Addie. When confronted with how easily his system could be manipulated, Jean-Charles de Borda, the inventor of the Borda count, said, "My scheme is only intended for honest men." In the next video, I'll talk about the other 2 major voting systems and the theorem that proved it's impossible to find a perfect voting system for 3 or more candidates.